From orbit, Earth's crust doesn't look like a smooth marble. It looks more like a battlefield of scars. There are huge ruptures carved by tectonic fury, ancient erosion, and unchecked human ambition. These aren't just surface-level scratches. They're vast, open wounds that tear across continents and fracture entire regions. In this video, we're going to count down 15 Earth cracks visible from space, each one revealing the planet's raw, untamed geology on a scale that's hard to ignore. Number 15. The San Andreas Fault. The fault is one of the world's most recognized and studied fault lines. It stretches over 1,200 kilometers across California, marking the shifting boundary between the Pacific and North American plates. Classified as a transform fault, it allows horizontal plate movement at a rate of 30 to 50 millimeters per year, creating a deep linear scar across diverse terrain. From the Gulf of California up to Cape Mendocino, it carves through valleys, mountains, and farmland. In Southern California, its trace is clearest at Carrizo Plain National Monument, where it forms a perfectly straight break across grasslands and hills. Major quakes, including the devastating 1906 San Francisco earthquake, have left permanent scars, with land offset by as much as 6 meters. Even without recent activity, satellites detect creeping motion along its length. Vegetation and landforms shift abruptly across its trace. From orbit, the fault line is stark, its path visible in shadowed topography, land contrast, and long, continuous surface deformations. Number 14. The Earth cracks of Badwater Basin. Badwater Basin in Death Valley isn't just the lowest point in North America at 86 meters below sea level. It's also marked by an intricate network of fissures and crustal cracks visible from orbit. Unlike classic rift valleys, these are surface-level fractures caused by a mix of tectonic tension, salt deposition, and extreme climate. Located in the Basin and Range province, the entire region has undergone crustal extension for millions of years, pulling the landscape into a patchwork of desert valleys and faults. In Badwater, salt left behind from ancient evaporated lakes forms brittle crusts that crack due to thermal expansion and contraction. The result? White geometric scars and salt polygons several meters across. Satellite photos capture larger fissures intersecting with fault lines at the valley's edge. Minimal vegetation and the basin's reflective salt flats make these patterns pop in high-resolution images. Beneath the surface, deeper faults still shift, and over time, the land continues to subtly deform under the desert sun. Number 13. The tectonic fissure of Thingvellir. Thingvellir National Park in southwestern Iceland holds one of the most visibly exposed tectonic fissures on Earth, the literal divide between the North American and Eurasian plates. This boundary marks the point where the two massive continental plates continue drifting apart. Their movement, averaging about 2.5 centimeters annually, is part of the Mid-Atlantic Ridge slicing through Iceland. The resulting rift valley, several kilometers wide, is one of the only places on Earth where such a plate boundary rises above sea level. The fissure is made up of sheer cliffs and exposed layers that show tectonic divergence over thousands of years. Its most prominent crack stretches over 7.5 kilometers and drops up to 64 meters in depth. Other fractures nearby form a jagged network across the terrain. These aren't just visible from the ground. They show up clearly on satellite imagery, with dark contrasting lines and shadow play across the mossy volcanic plain. Number 12. The East African Rift System. This rift system spans over 3,000 kilometers from Ethiopia's Afar Triangle down to Kenya, Tanzania, Malawi, and into Mozambique. It marks the slow separation of the African plate into two, the Nubian and Somali plates. Unlike isolated faults, this system is a continuous chain of fractures, grabens, and valleys that form an enormous scar across eastern Africa. Forming for over 25 million years, this rift is expected to eventually birth a new ocean, In Ethiopia, especially the Afar region, some of the deepest and widest rift cracks exist, with the ground torn apart by multiple meters. The 2005 Dabahu fissure added 60 kilometers of fresh surface rupture to this growing chasm. Southward, the rift creates deep valleys, steep escarpments, and long lakes like Turkana, aligned with subsiding crustal blocks. Satellite imagery highlights its geometric fault lines, crater chains, and escarpments, clear proof of Earth pulling itself apart in slow motion. Number 11. The Dabahu fissure. In 2005, a powerful geological event shook Ethiopia's remote Afar region, producing one of the most dramatic earth fissures seen from space in recent times, the Dabahu fissure. This rupture opened over just a few days during intense seismic activity. Stretching more than 60 kilometers and several meters wide in places, the crack was caused by underground magma forcing its way up, tearing the crust apart. The Afar Depression sits at the junction of the African, Arabian, and Somali plates, one of the most geologically active zones on Earth. This fissure marked the start of a larger tectonic process, slowly pulling the region apart and laying the groundwork for a future ocean. The rapid formation gave scientists rare real-time data on continental rifting. Over 160 earthquakes and a volcanic eruption from Dabahu accompanied the event. Satellite imagery and radar continue to track ongoing deformation and new faults. From above, the fissure appears as a dark, clean slash across the parched landscape. Number 10. The North Anatolian Fault. Turkey's North Anatolian Fault is among the most seismically active strike-slip systems on the planet, comparable to the San Andreas in scale and impact. Spanning roughly 1,500 kilometers across northern Turkey, it separates the Anatolian and Eurasian plates. This right lateral strike-slip fault causes horizontal movement, and over the past century, a series of massive earthquakes has ruptured nearly its entire length. These breaks have left visible scars, straight lines etched into valleys, fields, and cities. The 1999 Izmit earthquake alone ripped 150 kilometers of fault in one event, displacing the ground by over 5 meters. Satellite photos reveal these ruptures as zigzagging fractures cutting through landscapes and coastlines. Fault troughs, offset ridges, and linear lakes, including Lake Sapanca, add to the fault's visibility. The segment closest to Istanbul hasn't ruptured in recent decades, making it a focus of seismic concern. Space imagery captures the contrast in landforms along both sides of the fault, showing an unmistakable tectonic crack carved across Turkey's northern spine. Number 9. Lake Tanganyika Rift Fault. Along the border between Tanzania and the Democratic Republic of the Congo is Tanganyika, a surface marker of a colossal active tectonic fault. This isn't simply a lake, it's the exposed crest of the Tanganyika Rift, a major fault in the western branch of the East African Rift System. The depression is so profound that Lake Tanganyika reaches depths of over 1,500 meters, making it the world's second deepest freshwater body. The fault is slowly pulling the Nubian and Somali plates apart, and over time, this stretching has carved a deep rift valley now filled with water. The lake's flanks feature escarpments rising over a kilometer above the surface, clearly outlining fault geometry. Satellite imagery, MODIS, Landsat, Sentinel, reveals a near-straight 650-kilometer trench flanked by sharp terrain breaks. Earthquake swarms and GPS data confirm ongoing divergence. While the rupture lies mostly beneath the lake, sediment patterns and shoreline breaks reveal active scars. From orbit, it appears as a vast, sharply defined tear in Earth's crust. Number 8. The Jidatan Earth Fissure. High on China's Qinghai-Tibet Plateau lies the Jidatan Earth Fissure, an active surface crack born from both tectonic force and climate extremes. It's located within the Kunlun Fault Zone, a boundary where the Indian and Eurasian plates meet. The 2001 Kunlun earthquake, a magnitude 7.8 event, triggered enormous ruptures across a 400-kilometer stretch. Some fissures opened 2 meters wide, cutting through roads and reshaping water flow. These scars haven't faded. Synthetic aperture radar and GPS tracking show slow, ongoing movement. This region's freeze-thaw cycles only deepen the damage over time. Snow and rain sharpen the fissures' contrast from space, revealing long, dark lines across the plateau. The fissures align with the fault's hidden traces beneath the ground, running in nearly straight lines through sparsely populated land. While remote, Geodetan's significance is global. It's a rare example of how mountain tectonics and climate interact. Scientists monitor it closely, and it's for good. Number 7. The Kekarengu Fault. The Kekarengu Fault on New Zealand's South Island became globally recognized after the 2016 Kaikoura earthquake, when it ruptured the surface with violent clarity. The quake triggered movement across over 20 faults, but Kekarengu stood out with over 10 meters of horizontal displacement and a rupture stretching more than 30 kilometers. Within hours, satellites like Sentinel-2 and Planet Labs captured crisp imagery showing a clean, diagonal break running across farms, roads, and pasture. Fence lines and hillsides were visibly torn and shifted like a zipper across the land. The fault is part of the larger Marlborough Fault System, which handles strain between the Pacific and Australian plates. Its rupture remains one of the clearest examples of a modern strike-slip event, with offset stream beds and terrain features creating a stair-stepped pattern visible from orbit. Post-quake monitoring using radar, LiDAR, and GPS continues to track slow deformation. Kekarengu's raw, razor-sharp rupture offers a textbook case of horizontal plate movement, caught in stunning detail from above. Now let's move to Number 6. Shillong Plateau Fracture Zone. In northeast India, the Shillong Plateau stands as a tectonically uplifted block bordered by significant fault systems that manage crustal motion between the Indian and Eurasian plates. Among the most noticeable cracks here is one tied to the 2001 Assam earthquake, a 6.7 magnitude event that exposed a fracture zone along the plateau's northern edge, especially near the Dawki Fault. The region features sharp escarpments running for dozens of kilometers. From space, the Dawki Fault is a dark, straight boundary separating Meghalaya's highlands from Bangladesh's low plains. It stretches nearly 300 kilometers, marked by sudden elevation drops, fault-parallel ridges, and slope breaks. The 1897 Great Assam quake, believed to be magnitude 8.0, permanently reshaped this plateau's edge. Modern imagery, Sentinel-1, Google Earth, still captures the crack's signature despite vegetation cover. Near towns like Cherrapunji and Dawki, the fault line remains visible. Its preserved geometry and ongoing activity make it one of India's most prominent tectonic scars observable from above. Number 5. The Denali Fault. Alaska's Denali Fault is a major intracontinental strike-slip fault that runs more than 1,200 kilometers across the state's rugged interior. It's part of a broader system managing the pressure between the Pacific and North American plates. In 2002, it produced a massive 7.9 magnitude earthquake, one of the strongest ever recorded in the U.S., leaving behind a scar that's still visible from the air and space. Like California's San Andreas, it's a right lateral strike-slip fault, but Denali cuts through mountainous wilderness and remote parklands. The quake ruptured nearly 340 kilometers of land, with horizontal shifts up to 9 meters. Glacial moraines, ridges, and forest lines were sharply displaced. Even the Trans-Alaska Pipeline, built with seismic protection, visibly shifted, but held. Satellite imagery clearly captures the rupture, especially in snow-covered stretches where contrast is sharpest. The fault continues to accumulate strain, with GPS and radar detecting small movements. Denali remains one of Earth's most intact and exposed fault ruptures, visibly clean, incredibly long, and tectonically restless. Number 4. East Rift Zone. Hawaii's Big Island holds one of Earth's most visible volcanic crack systems, the East Rift Zone. Running southeast from Kilauea's summit to the coast, this active rift forms from the seaward slumping of the volcano's flank. As it shifts, tension cracks, rift valleys, and scarps appear on the surface. These are clearly identifiable in satellite imagery, especially following major eruptions. The 2018 Lower Puna eruption ripped open dozens of fissures, carving fresh lines through neighborhoods, forests, and roads. The black basalt from these eruptions forms dark, linear contrasts against older terrain. From orbit, the rift resembles a jagged ribbon of ruptures aligned with vents, lava tubes, and caldera edges. The USGS tracks this zone constantly using MODIS, Sentinel-2, and Landsat, capturing ongoing deformation. Unlike rigid continental rifts, this volcanic system is fluid and ever-changing. But its clean rupture patterns, minimal vegetation, and high lava contrast make it one of the clearest tectonic crack systems observable on the planet. Number 3. The Wadi Araba Fault. Southern Jordan's Wadi Araba Fault, part of the wider Dead Sea Transform system, slices cleanly through the desert as a tectonic boundary between the Arabian and African plates. Running roughly 160 kilometers from the southern tip of the Dead Sea toward the Gulf of Aqaba, this strike-slip fault creates a long linear valley that's clearly visible in satellite imagery. From above, the contrast between the highlands and flat plains on either side of the fault creates a bold incision across the land. The region has a history of major earthquakes, including the 1995 Gulf of Aqaba quake, which ruptured the southern section of the fault system and left visible surface offsets. Though the Wadi Araba segment hasn't ruptured recently, paleoseismic studies confirm repeated large quakes over thousands of years. One of the most striking segments lies near Garandal, where the fault bends and elevation shifts sharply. The lack of vegetation and high desert albedo make this fault line pop vividly in orbital views. Number 2. Baikal Rift Zone. Southern Siberia's Baikal Rift Zone is one of the most geologically distinct continental rifts in existence, home to Lake Baikal, the planet's deepest and oldest freshwater lake. Formed by extension between the Amurian and Eurasian plates, this rift continues to widen, carving a fracture that stretches over 2,000 kilometers. Its central segment lies beneath Lake Baikal itself, where the lake floor plunges nearly 1,700 meters deep. The surrounding Primorsky and Baikal mountain ranges define the rift's uplifted shoulders. From space, the rift is easily seen as a deep, straight trough, flanked by escarpments and shadowed slopes. In winter, snow cover enhances the contrast in satellite images. Major bounding faults, including the Sarma, Morskaya, and Barguzin, form clean, sharp lines across the terrain. Regular earthquakes and crustal extension of 4 to 5 millimeters per year confirm active divergence. Submerged fault scarps, as well as exposed breaks near Tunka Basin and the North Baikal Depression, make the Baikal Rift a pristine example of early continental breakup, caught in real time from orbit. Number 1. The Western Ghats Escarpment Fault. India's Western Ghats Escarpment, stretching over 1,600 kilometers from Gujarat to Kerala and Tamil Nadu, isn't just a scenic mountain range. It's a preserved continental fracture formed during the breakup of Gondwana roughly 100 to 130 million years ago. Though no longer active in a seismic sense, its sheer size, clean elevation drop, and geologic structure make it one of the planet's most visually impressive fossil tectonic boundaries. The escarpment marks where the Indian plate tilted as it drifted northward from Antarctica, forming the western edge of the subcontinent. Elevation jumps by over 1,200 meters in just a few kilometers, creating dramatic cliffs and steep transitions. Satellite imagery, from Google Earth to Sentinel-2, clearly outlines the fault's straight geometry, especially in areas like the Nilgiri Hills. Though erosion and uplift continue slowly, GPS and INSAR suggest minor vertical adjustments still occur. If you enjoyed this video, be sure to like and subscribe. Thanks for watching, and we'll catch you later.